Alright, hey, so I'm going to take a look at this question. We'll see how it goes. So, to me, this question looks like I'm trying to rewrite an expression in a new form. You can kind of tell when you're looking at this second form here. It looks very much like something where you need to complete the square. However, normally we're used to seeing completing the square as just maybe with a quadratic x squared plus, let's just do an example, 4x minus 8. We would be able to replace this x squared plus 4x with x plus 2, x plus 2 squared. And that would give us x squared plus 4x that we're looking for, but it also gives us an extra 4 out here. So we would just subtract that 4 and then also subtract the 8, and that would give us a new form, or like vertex form, of this quadratic equation by completing the square. And so that's kind of the same process I'm going to be using with this problem. However, we see, okay, we have a lot of differences between something like this quadratic down here versus our question up above. The most glaring of which is this isn't just one variable, there's more than one thing in there, right? So what I'm going to do is just redefine our variables so that we do just have one variable in there. Let's create a new variable, m, n, and k. So m is equal to x minus y, n is equal to y minus 3z, and k is equal to x minus z. If we do that, then we're going to have some m plus a squared plus some n plus b squared plus some k plus c squared here. Oh boy. Sorry, just clicked out of the tab for a second. But our goal here is to have this form. This is the same exact thing as we have up here as our goal, right? But in order to get to this, we're going to need to put these variables over here, our 6x minus 8y plus 14z, into our form of m, n, and k. Okay? And so at first, I'm kind of thinking, well, how could we do that? And the answer that I landed on was, well, right now everything is written in this basis of x, y, and z. It's written in terms of those three variables. If we want it written in terms of m, n, and k, we can just perform a change of basis. And so hopefully you've seen something like that before, but we're going to have to use a little bit of linear algebra to think about how we can convert one basis to another. So I have some stuff queued up on board number 2 here. I actually wrote what our m, n, and k vectors are in terms of our x, y, and z vectors. So when I think of x, y, and z, I'm thinking of our normal basis where x is equal to 1 times I hat, which is this vector here. Yeah, if it's not super clear, if you haven't seen this before, the vector just being the vertical column of the matrix. So I have I hat, j hat is y, and k hat is z. And so hopefully you can see why m, let's just call it m. Let's just call them m, n, and k are represented by these vertical vectors. If not, I encourage you to just kind of take a look at how these would be scaling x, y, and z. But hopefully that makes sense, you would agree. And so when I'm writing m, n, and k in terms of x, y, and z, that would be a change of basis matrix from that a vector written in that m, n, k basis to x, y, and z. But we actually want the opposite. We have this vector 6x minus 8y plus 14z. We can think of that as this vector 6, negative 8, 14 in the xyz basis, and we want to convert it to m, n, and k. So that's why I did what I did here, which was augment this matrix on the left with our identity matrix. I don't know why that took me a second. And then what I would do here is row reduce, because that will invert this matrix, making it the change of basis matrix that we want from the XYZ basis to the MNK basis. So I'll save you some matrix, row reducing, algebra, whatever. Hopefully, if that's something that you need to show work on, you can do that on your own. And I think it's a great exercise to do either way. I would really encourage it. But for the purpose of this video, let's move on over to board number 3. This is what happened when I went through that process of row reducing to invert that matrix. I got this guy. And so in order to convert this vector from the XYZ basis to the MNK basis, I just multiplied it by this change of basis matrix I found, and I was able to get this new vector 2, negative 6, 4. And so what this represents is 2m minus 6n plus 4k. So that means that 6x minus 8y plus 14z should be equal to 2m minus 6n plus 4k. And I promise you it is, but I leave it to you as an exercise to verify that as well. I'm going to run back to board number 1 here, and I'm going to kind of clear off a lot of what we have so that we can rewrite this as we would want to. So remember, we're going to replace everything in this top equation here with the m, n, and k variables. So remember, this first thing is going to go to m squared, and then n squared plus k squared. And then this part, the 6x minus 8y plus 14z, that we're going to change to our 2m minus plus 2m minus 6n, and then plus what, 4k, plus 4k. And so now our final step is going to be completing the square. We're going to group the m terms together. We have m plus 2, well, we're going to have m squared plus 2m. We want to complete the square with that. That would be m plus 1 squared. It's going to give us that m and the 2m. The problem with that is it's going to give us an extra plus 1, right? So we have to cancel that out by subtracting 1 after. So we have that m plus 1 squared and then minus a 1. And now let's do our n terms. We have an n squared and a minus 6n. So to complete the square, we want to take this negative 6, divide it by 2, because whenever we're completing the square, like I guess whenever we're squaring a binomial where we have a variable term and a constant term, it's going to end up being n squared plus 2 times that constant term, so in this case negative 3 times n plus that constant term squared. right? So we divide that by 2 to kind of figure out what we want to put in there as b. And we decide to put in -3. But again, that'll leave us with this extra +9, so we have to subtract 9. And then same process with k. We have that k from here and a 4k here. So we know if we do k plus 2 squared, that should give us k squared plus 4k that we want, but it gives us an extra 4 too, so we have to subtract that off. So our final version of this expression is going to be, let's see, I wish I could scroll down a little bit. Oh, what I think I can do though is just move this whole thing up, potentially. Well, oh, I'm sorry, I'm still a little bit new to this software. So that arrow is kind of coming with, but hopefully that doesn't totally mess you guys up. I guess I can just erase the arrow. So my final version of this expression is going to be m plus 1 squared plus n minus 3 squared plus k plus 2 squared. And then I'm just going to group all these constants together. So I have -14. So I know that isn't exactly this form above, but as you can kind of see, it's not going to be possible to put it in that exact form above because you're always going to need an extra term to correct when you're completing the square like this. So I'm hoping either you or your teacher, whoever asked, just forgot to add a little plus d at the end, because I think this is the closest we can get to that form. So hopefully that made some sense. Feel free to ask follow-up questions. I know I brushed over a lot for the sake of making a video that isn't too horribly long. Yeah, hopefully this made sense, but I would be happy to dive further in depth in any of like the specificities that I just explained. So good luck. Thanks for watching. Yeah, bye.